Hi, this is Omar. Today we are going to talk about 3 experiments. We'll start by porosity experiment, and then we have 2 more experiments, fluid saturation and phase behavior. So in porosity experiment, we usually use, or in the system that we have, we use, or we call it gas porosimeter or helium porosimeter. So the idea depends on, or the principle of work depends on Boyle's law. And Boyle's law states that PV is constant as long as we preserve our isothermal conditions. And since we are going to do the entire experiment at ambient conditions, then it can be considered as an isothermal process. So we know that PV equal constant, and therefore P1 V1 is P2 V2. So if I have a chamber that has some kind of gas, and this gas has a pressure of P1 volume, and the chamber volume is V1. If you connect this chamber to another chamber, like open the connection between them, the pressure will drop, right? And the new pressure, we will say that P1 V1 will be equal to the new pressure in the system, which is P2 multiplied by the entire volume of the system, okay? So V2 in this case will be equal to V1 plus V nu. V nu, I'll assume that V nu is equal to the new chamber volume in addition to the connection between them. So this is the principle of work. We will apply this principle in our experiment 3 times. The first time, we will have one chamber full of gas, and then we will connect it to another chamber full of pellets. Pellets are solid items like these ones. So we will fill our chamber completely with these pellets. Second time, we will remove a certain number of pellets and leave the rest. In the third step, we will add our core, or our rock, in addition to the pellets. So it will be on top of the remaining pellets. So why are we doing all these steps? First, as we said, we will adjust our first chamber pressure, and we know the volume, and then we will connect this volume to a chamber full of pellets. In this process, we try to get a reference volume, or actually the volume of the connection in addition to the volume of the first chamber. And then we'll use this volume in order to get to our reference volume. What is a reference volume? It's the volume of everything other than my grains. Why am I doing that? Here, let's say this is P1 V1, and when we open, if we have a certain number of pellets, a smaller number of pellets, that will fill the additional space in addition to the volume of the core, then I know this volume in addition to this volume and this volume. So here is empty, here is empty, here is empty, or rather full of gas. And these are the additional pellets that can substitute for the remaining volume in order to fill the entire chamber, remaining volume in addition to the core. So third step will be, we will keep the same configuration, we just add the core on top of the pellets. So how do I calculate the number of pellets that we have here? It's easy. You put your core on a bench, and then you start to form or to add the pellets atop each other until their height is similar to the height of the core. So how do we do that? Let's say these are my pellets and this is my core. So I put them on a bench beside each other, and I keep adding pellets until their size is almost the same as the core, like this one. I'm not sure if it's clear or not, but this is a small clearance. There is a small clearance between them, but that's okay. So in this case, if I had all of these pellets inside my chamber, then we remove the ones that have the same volume as my core, and I keep the rest in the chamber. So these ones go in. So in this case, when we do that, we can get a reference volume before I put my core. This reference volume says that from this law we will be able to know the volume of everything except for the grains of the rock that are going to occupy this space in the future. So usually the equations are easy or are forward ones. You will find them in your handouts, but this is just the principle of work or the idea of the experiment. So in the beginning, we put a full stack of billets inside my second chamber and get the volume of this connection and that chamber. In the second part, we remove a volume equal to the volume of my core, and I get the volume of this region plus the connection plus that first chamber, and then I put my core in here, and this way I'll be able to estimate the volume of the grains, which is going to be the difference between the volume V2 here and V2 here. So this is the idea of the experiment. Now we will go to the system and see how to do that. It's going to be a little bit boring because the steps are too long, but we have to follow them step by step so that the experiment goes well. So now we start our porosity experiment. So as you see, this is the first cup, or actually the second cup, the one that we put our billets and core in, and the first one is inside the instrument. The first step is to prepare the instrument, make sure it's not leaking or anything. So in order to do that, you open this is your supply gas valve, make sure it's open. Open means it's in the horizontal direction, closed is in the vertical direction. So make sure the valve is open, and then start to adjust the gas regulator until the pressure readout in here is around 95 psi. This is the pressure reading inside the first cup. And make sure the other two valves, the venting valve and the valve connecting the first chamber to this chamber, is closed. We call it two-core valve. You will find the detailed procedure in your handout. This is actually what I'm reading from, so I'm doing exactly the same steps. So in order to adjust the gas regulator, either use this knob or there's another knob on the back. So start rotating that knob until you build up pressure of 95. So now I am at 85, and close, okay, 93, and 95. Okay, it should be between 94 and 95. Now it is 95.01. Then we close the supply gas valve and see if this pressure decreases or is kept constant. In my case, we wait for 10 seconds. That should be enough. If the pressure is okay, it doesn't go down, that means there is no leakage. If it goes down, there is leakage. But in my case, as we can see, it's still 95.01 or 95, so it should be fine. So now we made sure there is no leakage. Now we can vent everything. So we open the vent valve and we open the two-core valve. Now the pressure goes back to 0. I'm not sure if the reading of the pressure is clear actually here. Let me bring you closer. So next step is, you remember we had 3 steps in our experiment. Now we start the first one of them. So we close the 3 valves, this one, this one, and this one, and then we open the supply gas valve, and we try to bring the pressure should go back to 95. If it doesn't, we need to adjust it manually. Again. Oops. So sometimes it goes above. In this case we need to vent and repressurize again. So let me bring it back. To 95. So I'm moving the knob slowly because I don't want to exceed the... Oops, now should be good. Should be good. Okay, 94.73. So we wait for a few seconds, like 10 seconds or so, and then we close the supply gas valve. It should be enough. Let's close it, wait for 10 more seconds, and then we open the vent and the 2 core valves, and we record the pressure in the full cup data section in your data sheet. You will have calibration data, and you will record the pressure you will read under the full cup pressure. Sorry, zero pressure. Full cup data, zero pressure. This is your zero pressure. So let's open the vent and to core. My pressure is 0. So the zero pressure in this case is going to be 0. Okay, next step is to fill this with all the billets. So let's put our billets in there. And then cap it with its cap, and after that you put it in this, in here. You just make sure it's tight. After that, close it. So we close this valve and we close this valve. So let's open our supply gas valve, and it would take us to almost 95 or 94, close to the pressures that we had. So next step is, after leaving it for some time, we close the supply gas valve. So now we know, now we prevented any connection between the gas cylinder and our chamber. Now I'm going to open the connection between the first chamber and my chamber that's full of pellets. But before doing that, we need to record what full cup reference pressure, which is this pressure. In our data sheet it will be called full cup reference pressure. And this is like the pressure in the first chamber. After that, we open the 2 core valve in order to connect the 2 chambers together. So after we do that, you will find that the pressure started decreasing, became like 77.5, and we record that pressure as the full cup pressure. Okay, so we wait until the pressure is constant and then we record it. Now we have finished the first step of our experiment. So we can go and open the vent valve, and then the digital reading will go back to 0. Okay, so after that, when the pressure is 0, you can open your chamber that had your billets and take the billets out. After taking the billets out, let's bring our core. And as we said in this illustration, we need to measure the volumes and get the number of stacks that makes almost the same volume as my core. This is higher, no, higher is not acceptable, a little bit lower is okay. So let's take these two as the ones that are equal in height. So the rest of them, we need to put them with our core. And also you will need to record the ID of the stack of the pellets. These two pellets IDs are C and E. So on each pellet you will have a letter in the middle of the pellet. This one has C, this one has E. I'm not sure if it's clear or not. And the others are A, B, and D. So you record the ones that you remember, C and E. After that, we take the extra pellets and put them inside your chamber. Or actually, should be slightly taller, not slightly shorter. So slightly taller than the core. I'd rather use these ones. Okay. Let's consider D and E as the ones I'm going to remove, and the rest are the ones I'm going to put inside my chamber. So after that, we need to close that again, and after closing it tightly, go back to our instrument. So we need to close the vent and the pour valve one more time. And after closing them, you open the supply gas valve. It should go back to close to 94 point something. And wait until it stabilizes, same process. Similar steps, and you record this pressure After it stabilizes, you close your supply gas valve and wait 10 more seconds to stabilize, and then record the data under removed billet data section in your data sheet in this section. So here you record the removed billets ID number, which are the ones that we left outside, and the removed billets volume as well, and the removed billet cup reference pressure and removed billet cup pressure. These are, the first one of them is the pressure that we have right now before opening the tube core valve. Once we open the tube core valve, we will get the removed billet cup pressure, and this will be our second pressure. So let's open the tube core valve, and now the pressure is 26. So let's wait until it stabilizes. So you remember that V2 in this case is very small compared to the one that we had in the previous run. The previous run was 70 something, I think. So because now we removed a lot of billets from inside the second chamber, so it's empty, so the pressure will go down more. So now we record this pressure, 25.97, as my removed billet cup pressure. After that, you go to your handouts, you will be able to get the volume of our reference volume from this equation. You have the volume of removed billets, you have the reference pressure of the removed billet section, and you have the cup pressure from the removed billet section. You have the reference pressure from the full cup section, and the cup pressure from the full cup section. So substitute by these four values, we have already measured them, and you already know the volume of the removed billets. How do you know the volume of the removed billets? In this next page of your handout, you'll find that each billet of these has a volume, and you can use that volume. So now we have finished the second part of the experiment, where we do get the reference volume for my experiment. Now I know the volume inside, the additional volume inside this chamber, along with the connection into the first chamber, along with the volume inside the first chamber. So what remains is put my core in here and repeat the steps. In this way we will be able to get our grain volume. How do we do that? First, let's open our vent valve to reduce the pressure. Then we open here, one more important note, we usually need to take the weight of our core, but we can do that with any balance, so that you have the weight and the final equation. So we put our core and we close our cap. And then we put it back in its locker here and make sure it's tight. So after that, we start repeating what we did again. So first close these two valves, open your supply gas, check go back to 95 or 94. And let's wait until it stabilizes. If it's stable, not yet. Okay, should be good enough. Close the supply gas valve. Now we isolated the nitrogen cylinder. So wait again for 10 more seconds. And record this pressure as you are removed, where to say, last section. System reference pressure. This is like your last reference pressure. And after we open the two-core valve, we will call this pressure the cap sample pressure, which is the last pressure you will record here. So now we will open the two-core valve, and the pressure goes down to 50 something, because now we have the core. So this is actually the last step. Now you have all the data you need to do your calculations to get the grain volume. So instead of having several Boyle's law equations and several substitutions, the instructor has substituted with all the equations together and gave you only one equation, in addition to the one that you have already used in step 2 to calculate the reference pressure to get the volume of the grains. So you just substitute in this equation. Just one little problem, as I remember. The sign, like the part on the right hand side of this sign, of the negative sign, should switch sides with the part before it. I mean inside the second bracket. So these pressures should go here and these pressures should go here, something like that. Or if you don't do that, actually you have a modulus here, so it's not really a problem. Anyway, now we just need to shut down the system, take out our core, and return the system into the state it was before we began the experiment. In order to do that, we need to open the vent and two core valves. The core valve is already open, so pressure reading is 0. Now I can open this chamber, get the core out and the remaining billets. So after that, this experiment should be done. Okay, the rest is for me. Now we will start our second experiment.